So this is going to be the power rule proved for n is an integer. Now, there are proofs for n is any real number, but I am just going to do the easier one because you need a lot more information or a bit more information to prove all of them. So right now we're just proving d over dx for x to the n equals n times x to the n minus 1. So what I did was I wrote the difference quotient, and that's just the definition of a derivative, right? So that's the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And then I just input x to the n into it, and I got x plus delta x to the n minus x to the n over delta x with the limit as delta x approaches 0. Now, you'll notice that x plus delta x to the n is a binomial, so we will be using the binomial theorem over here, which I wrote already. So the binomial theorem works for any binomial, and it's used to help expand all the terms, which is going to be incredibly useful, especially when you have something like a power to the n and you just want to determine you just want to expand it with the nth power, which is all we need. So our very first step is going to be just writing our next line, which is going to start with limit as delta x approaches 0. And what we're going to have is a super long thing over here, and I'll show you why in a second. Now our first term, if we're expanding x plus delta x to the n, what that's saying is x plus delta x times x plus delta x times x plus delta x times x plus delta x, and you're going to do that n times. So if you think of something like a plus b squared, it's kind of a no-brainer that the first term is going to be a squared, right? Because you're going to have a times a on the other end. Now you're still going to have your 2ab plus b squared, but that's not relevant. What we're worried about is our very first term. Oops. Our very first term is going to be x to the nth power, similar to how the other one was a squared. So we're going to have x to the nth power. Now our next term is going to be using the binomial theorem. You could use the binomial theorem for this first term. There's no reason you couldn't, but it's overly complicated. You don't really need to. But for our second term here, all we're going to do is, instead of evaluating the whole thing, we're just going to say n choose 1. And that deals with all of the combination aspect of the binomial theorem. And we can just come back to that when we actually need to expand it, which will make it way easier. So n choose 1, and then we're going to have x to the n minus 1, and then delta x to the 1. As you can see here, k is now going to be 0. N choose 1, where k is 1 now. You're going to have a to the n minus 1 and b to the 1. In this case, we're just going to have x to the n minus 1 and delta x to the 1. Right, so next we're going to be doing n choose 2. N choose 2. And that's going to be x to the n minus 2. And then we're going to have delta x squared. Okay. And then beyond that, we're going to have plus. And then this is going to keep going on however long n is, right? It's going to happen n times. So I'm just going to put dot, dot, dot there to kind of symbolize that, it's just going to go on forever. Right, but we know that our last term, which is what we need here, our last term is going to be delta, here I'll explain in a second, it's going to be n choose n, and that's going to be delta x to the nth power, because when k is equal to n, it's n choose n, right, and the combination of that is just going to be 1. And what we're going to get here is a to the n minus n, which is a to the 0, which is going to be 1 times b to the n. And b in this case is delta x, so it's going to be delta x to the n times 1, which is where this went. But yeah. And then we still have our minus x to the n over here, so we're going to add that on to our n, or to the end here. And what you should notice, hopefully right away, is that x to the n and minus x to the n are going to cancel, or, they'll become 0. And on our denominator here, we're going to still have our delta x. Now, with that being said, we can now factor out, you'll notice, a delta x from each one of these terms. Every single one of these terms, you're going to have a delta x here, a delta x here, a delta x here, and every delta x in between all of these infinite terms there. So what we're going to do is we're going to bring it down a little bit more. We're going to say this equals the limit as delta x approaches 0 and we're going to have delta x at the bottom, and I'm factoring out this delta x here, right? And then we're going to have everything else inside. So this is going to be n, choose 1, x to the n minus 1. This delta x was factored out, so it's not going to be there. Also, I'm going to separate this just so you know with a bright color. This parentheses, all right. And we're going to have plus n choose 2 x to the n minus 2 delta x, because it's not delta x squared anymore, it's just going to be delta x because we factored out that other delta x. And this is going to go on forever, or for n times, whatever. And then we were picking it up at the end, and we were just going to have n choose n, which will be delta x to the n minus 1. Now the big takeaway here is these n's over here, or delta x and delta x here, these will cancel, right? And then we're just going to be left with this this right here. We're just going to be left with all this. Now we're approaching the end here, and what we're going to do is I'm just going to write it out again for the last time, and we're going to have the limit as delta x approaches 0, and we're just going to have all of this stuff here. So that's just going to be you know what, I might as well just copy this over here. So here, wait, let me just copy it here. Looks a little bit weird, but it's fine. So you'll notice that here, let me just actually just so I can, never mind. Okay, yeah, so as delta x is approaching 0 here, you're going to notice that everything with the delta x, this term here, is going to be approaching 0 as well, right? So if this is approaching 0, then we don't have to worry about it. And the same for every single one of these and here. So as delta x is approaching 0, all those terms that have a delta x in them are going to approach 0 as well. And what that's going to leave us with is just this very last bit, which is going to be that one delta x that got factored out, and we canceled it. We're just going to be left with it right here. I'm just going to rewrite it so it looks neater, and I'll write it in a bright color. So we're going to have n choose 1 of x to the n minus 1. You can notice there's no delta x in here anymore, so our limit is no longer relevant. And what we're going to be saying now is n choose 1, we actually need to evaluate it now. And what that is just going to be n factorial over n minus 1 factorial times 1 factorial. And this is just going to equal n. You can work that out if you want, but just so you know, that's going to equal n. So if that's equal to n, and this is now n, right? Then I could just say n times x to the n minus 1 is equal to our derivative up here. Let me circle this. It's equal to this right here.